I think that evals actually have not changed much over the past several years. Like I've been doing evals since 2016. And one of the reasons I actually was excited about starting Braintrust is from then all the way through when I was working at Figma, very little had changed about evals, even though the things we're evaluating and some of the metrics and blah, 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 all this stuff is changing, but the discipline itself hadn't changed. And that gives me a lot of internal conviction that 8 years from now, evals will still be very relevant, and they'll be kind of like the core driver for how people build great AI software.
To get started, thank you everyone for being here. This is the third session of Greylock's Change Agents. As many of you know, Change Agents is this new speaker series that we're putting together that explores what it means to be building agentic software. And we're doing this through conversations with researchers, CEOs who are really at the forefront of building agents. Tonight we're joined by Ankur Goyal, founder and CEO of Braintrust. I'm Corinne Riley. I'm one of the partners here at Greylock. I spend all my time in B2B AI applications and infrastructure, and I have the privilege of being an investor in Braintrust since the seed. So Ankur, thank you for joining us at Change Agents. To get started, why don't we have you do an introduction of yourself, tell us about the inception story behind Braintrust, and tell us a little bit about what Braintrust does.
Awesome. Thanks for having me. And thanks everyone for being here. Nice to see some folks. I've even met some folks who I've only seen on Slack before in person, so that's pretty fun. So yeah, a little bit about Braintrust and how we got here. Prior to Braintrust, I started a company called Impera, and that's actually when I met Corinne and Sam. I pitched to them a bunch of times, and they said thumbs down, but it was still really nice to get to meet them and really stay in touch and build a relationship. To anyone who's starting a company, I think when you meet investors and you actually really like them, sometimes they'll say no, and it's pretty important and valuable to actually use that as an opportunity to get to know them for the future. So just a little thing to think about. Anyway, at Impera, we used language models, and we ran into all kinds of problems when we actually tried to create products that people used with those language models. So we primarily built a product that helped customers extract data from business documents, and we had two big use cases. Financial institutions used us to get data out of banking statements, and a lot of other companies, like all kinds of companies, used us to extract data out of invoices. And we'd frequently improve the performance on one of these things and regress the performance on the other. And a lot of the culture around AI, especially at the time, was very academic. So you'd run a benchmark and you'd see, hey, we've gone in aggregate from 82% to 86%, and everyone would get really excited. And then you ship a new version of a model or a prompt or a system out to a customer, and maybe that 4% improvement was like 10% better at invoices and 6% worse at banking statements. And then you have a banking customer who's very unhappy. So we had to learn kind of the hard way how important it was to actually evaluate things before we ship them to customers, and then learn from what customers were observing while they were using our product, and drive that into building better systems. And we built internal tools at the time to do that. We tried a bunch of things that didn't really work. This was a few years ago. And honestly, I didn't think too much of it at the time. But then we got acquired by Figma, and I led the AI team there. And that happened right as ChatGPT was coming out, and so everything was changing. We didn't even think about building our own models. We started prompting the pre-existing large language models, and we actually ran into exactly the same set of problems. And we built pretty much exactly the same internal tooling to help us do evals and get good data from real users and work them into our evals. And after doing that twice, I was talking to Elad, who's one of our investors, and he was like, hey, you've built the same thing twice. Maybe other people have this problem now that you're not just the only, one of 3 people or whatever working on AI like we were back in the day. And so we talked to a bunch of companies, and that's when we realized, like, hey, pretty much everyone has this problem. Some of our first users were companies like Zapier, Coda, Airtable, Notion, who are really ahead of the curve and actually incorporating AI into their products. And now I think are very much leading the way with agents, which would be great to talk about in a bit. And so we realized like, hey, maybe this is a problem that a lot of people have and even more people will have in the future. And that's what led to starting Braintrust.
Awesome. And so tonight is all about evaluating agents, as you just said. And obviously Braintrust does even more than that. But actually, let's focus on that. Why is evaluating an agent or an agentic system different or even more complex than traditional software, but also just your single shot LLM output?
I think it's not.
Okay, hot take.
Yeah. I think that I'm of the mindset that agents are a very natural evolution of AI software, and AI software is a very natural evolution of software. And I actually think, on average, I certainly see this with some of our more sophisticated customers, the resulting agentic system that people build is actually dramatically simpler than the previous generation of software. Like, yes, it is more powerful. The model may be doing more steps independently. The user experience may end up being more sophisticated or more expansive in terms of the task that it's doing. But the actual code and the logic in the code is dramatically simpler. And I think the prevailing architecture for agents is a for loop with tools. And that's like pretty much every major agent. Deep research, for loop with tools. Claude Code, you can read the code. It's a for loop with tools. And that's actually like way simpler. But like 6 months ago, before Claude 3.7 came out and Gemini 2.5, which I think are particularly good at this, people were building like the types of terms that we'd see are like nuclear reactor graphs that were submitting airplanes into the ether and then like twirling around and doing backflips and then interrupting users, and it's just like all this stuff that just doesn't exist anymore. And so I think agents have actually made the simple paradigm of like basically I'm writing a system prompt and I'm kind of crafting a software system around it, primarily the tools, a much simpler thing to actually engineer. And I think correspondingly, evaling a modern agent is actually quite simple. The people that do it best, they basically split up their evals into two kinds of evals. One are end-to-end evals, and you can think of these kind of like integration tests in traditional testing. These are tests that basically give the agent the same type of input that a user would, and then they let the agent run for a while and generate whatever its end result is, and then evaluate that with the same type of metrics that you'd use that a user might use. So, for example, someone here is from Pylon. Pylon's a really cool customer support product. We use them, and a good example might be that there's like a customer question that comes in, and you want to evaluate the entire journey of taking a customer question and then using a bunch of resources and tools, blah blah blah, but letting it run for a while, generating a final response, and then actually evaluate the final response. And that evaluation actually looks quite a bit like the single-shot prompt evaluation, where you have an input, you have some system, you have an output. There's some challenges, like these things can take longer, they can break more, et cetera. And there's some really valuable metrics you can track, like error rates and the length of a trajectory and some other sort of secondary metrics that give you insight into performance, but it's quite simple. And then the other thing that people test, which I think is where a lot of the interesting work happens, is actually capturing individual steps or interactions of an agent and trying to refine those. And there, I think tracing the right shape of an agent's interaction is very important. To give you an example, if we continue using that Pylon thing, like let's say the Pylon agent looks up something on your documentation website as some step to be able to answer an initial question that a user had, that specific lookup might go wrong. And it might go wrong for a variety of reasons. Maybe the query that it actually looked up was bad, or maybe they're not using a vector database yet, and it's just scraping a page, and the page has too many tokens, and so it runs out of space and returns an error. And I think it can be super valuable, to actually capture those individual steps and then save those as data sets and actually evaluate the individual steps themselves. And I think it's the sort of third thing that I find very productive is actually trying to figure out how to run evals on these individual steps, improve them, prove with evals that you've made some progress, and then rerun the end-to-end tests and evaluate those. And I think that's quite fruitful because if often you'll see an improvement, and that's great. You can sort of correlate the individual step improvement to the overall system, but sometimes you don't. And when you don't, it is also still a useful sign. It might mean that your overall eval is too brittle. It might mean that your overall eval is not actually incorporating this edge case that you fixed in the first place, and maybe it should. And so I think thinking about the relationship between these two kinds of evals and using them to improve the overall system is also quite useful.
And then on that topic, so two different kinds of systems, maybe even more techniques under the hood, right, that you can use. Like, let's say I'm a team getting started today. How do I go out and figure out which of those techniques is right for me and doing that type of experimentation around what the evals themselves should be?
Yeah, I think that's a great question. And one thing I would sort of discourage is trying to do a lot of planning and prep work before you start doing evals. I think that a lot of the things that I'm talking about, one, I might be totally wrong / I'm not perfect, so I don't know everything. But two, these are all learned experiences from building AI software ourselves at Braintrust and also working with some really great customers who are at the forefront of this and just talking to them and sort of solving some of the challenges that they have together. And so I think it's actually really important to write a relatively crappy prototype of whatever your product is. And maybe if you're thinking about something agentic, you can fake it. Like maybe actually use a single prompt and let it hallucinate some of the steps that it might run, or don't let it run some of the intermediate steps. But create like a very simple prototype that you can actually incorporate into a product and then use it yourself. And that's a great way of actually building intuition about where the system does well and where it doesn't do well. And more importantly, you should be able to go from a bad interaction that you have into a test case, like I just described, for either an end-to-end eval or evaluating a specific step. And if you don't have the systems in place so that when you experience one of those bad things that you can like immediately and quickly do that, then you have no hope when users are actually using your product and saying like, hey, knock, 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 this thing sucks. And you want to be able to capture that when people actually use the product. So I would just start there, like create a simple prototype, use the prototype, and make sure that when you use the prototype and something doesn't work very well, you have the systems and workflow in place to be able to turn that into an eval. And then you have a basic eval, and you can keep iterating as people actually complain and incorporate their feedback.
And how do you think about, how do you know if the problem is the underlying prototype or the application or the eval itself, right? Like how do you continuously improve your evals over time?
Yeah, I think the key is to use your human brain. So I think of evals in kind of a simple way. If you zoom out, an eval is a way for us as humans in our remaining years as productive organisms to reconcile what a model is producing with what we expect. And for at least the next 24 hours and potentially the next few years, and unlikely the next 100 years, that will be something that we can all find value and meaning in. But at the end of the day, that is an eval. Like you're just reconciling what a model says and what you expect. And there are, to your question, how do you know if the eval is bad or the thing is bad? The key is to actually just look at stuff. So when I run an eval, every time I do, I look at two things. One is, what are the specific tests or the cases that got worse versus my previous eval? And when I look at that, I think, okay, great. Are these things actually worse? And if so, let me play with them. And that's great. My eval found something that's bad. Yay! Now I can improve it. Or I look at the things that are worse and say, what the hell? This Levenstein string difference thing that I'm using is clearly missing the nuance here, and dog and canine are actually the same thing, and so it shouldn't be penalizing me for that. And when you observe that, that is the moment that you should say, okay, I'm not going to change my agentic system or prompt or whatever. Now I'm going to change the scoring function and run another eval or run enough evals that I can make sure that this human intuition I had is encoded into a strictly better system than it was before. The other thing I look at is improvements. And improvements you should look at with exactly the same skeptical eye that you look at regression. So if you see something improved, immediately you should ask yourself, did it actually improve, or is it a fake improvement? And I think when you're getting started, honestly, most of the improvements are fake improvements. And guess what? That is a perfect opportunity for you to look at your eval function and figure out how to actually improve it.
That's a good segue actually into the next question, which is, if you think about the metrics that you're looking at, and if we very rudimentarily say there's quantitative metrics and more qualitative metrics like coherency and stuff like that, like how do you think about how much weight should be put into each of those buckets? And if I'm a new user using Braintrust, how do I understand the difference in those improvements or not? Yeah,
great question. I think the biggest misconception about evals is that they're benchmarks, and I don't think evals are benchmarks. So when I run an eval, if something says 24%, I don't care. If Brian is creating a separate app and he says, hey, my evals are 72%, and I'm creating a different app, and my evals are 24%, that means nothing. The only thing that matters is if I run another eval, how can I use the numbers from the eval that I ran before to help me not waste time when I run the next eval? And so I think of evals actually as a very effective way to prioritize your human time so that you can use your time effectively to improve the AI system. And I actually think the only thing that matters is looking at differences in eval results from one iteration to the next.
And if you put that back to the fact that you don't believe that agents are fundamentally different from other types of evals, but if you put into the fact that agents can get very complex, right, with all these steps, it becomes hard to tease apart like the different parts of where something might be improving or not. Yeah, how actually would you recommend to a team to tease apart agents, particularly as they become very complex and multi-step?
Yeah, I think you want to think aspirationally. And if you sort of think of yourselves, whether you're building, a very, like an application itself, like I'll continue using Pylon, as an example, or maybe you're building something lower level in the stack. But let's use Pylon, and let's say you're building an agent. Maybe you actually have like a really ambitious aspiration for what support can be. And maybe, in the future, I'm just making this up. You should at some point correct me if there's a better way of thinking about Pylon's vision. But maybe when Claude 8 comes out, you will be able to scrape the internet for any questions related to Pylon and build features automatically based on what the person is asking for in the customer's product, and then follow up on the form. I'm just making this up, right? It's like some very aspirational thing that we maybe think, maybe this could actually work today, but you might think it might be challenging to make this work. I think it's actually like great to think about those scenarios and encode them as these end-to-end evals that I'm talking about, and write the code and actually construct the data in a way that these very aspirational evals are somewhat durable. So if you imagine an eval like what I just described, whether you're using a for loop with tools, or you're using that nuclear reactor thing, or you have a single prompt, or maybe something else in the future, the input and output and some of the intermediate materials to actually help you solve that problem, they don't really change. And I think those are very durable evals. You're not going to score well on them. If you score well on them, then you should go home. You shouldn't score well on them. And you can use those as kind of like a way for you to continue measuring and improving performance every time you try to change something. Like if you have evals like this and Claude 4 comes out, it is incredibly valuable to just swap a new model and try running it on these evals and then answer the question of, okay, great, what use cases were out of reach with the current generations of models and suddenly become in reach. And you don't have to change a single line of code, right? It's not trivial to engineer those things, but I think it's a worthwhile effort to do. And then you have these more incremental evals, like you're building this super complex system, maybe you have a router, or maybe you have like some sort of retrieval tool, or you have a calculator, I don't know, whatever. You have something like quite specific that is somewhat relevant to the implementation. You know, a good example, the code gen tools the code gen companies will often have some compilery stuff as tools like a linter or, you know, like a compiler that verifies the code that the model generates is valid. These things have gotten simpler over time because models tend to generate more valid code every iteration. So maybe you need one of those things to be really good in the current generation because ShadCN came out after the training cutoff date. I'm just making this up, and you know, whatever. You sort of need this right now, but you may not need it in the future. And I think it's okay to sort of engineer these relatively specific evals and keep evolving them over time. And you don't necessarily want to make these as durable and what's the word? Carefully engineered as the first category, which it's just very important for those evals that you don't, no matter what you change, you don't actually really need to change the eval.
And you started talking about like scorers, right? And you know, how do you think about if I'm a new team getting started? Is there this out of the box, you know, scoring stack that I'm using? And at what point does it make sense for me to have like my custom scoring stack?
Yeah. I mean, every out of the box stack that we've evaluated sucks. So I don't generally recommend using them. And we like are as incentivized as anyone could be that there should be a good out of the box scoring stack, right? Because it would help Brian and team be like, hey, just use our recipe or whatever, and then like you don't need to think about this. It just doesn't work. And I think part of the reason is that when you're building an AI system, the stuff that you're evaluating is like literally the thing that is distinct about your about your AI use case than anything else. Like if there was nothing specific about your use case that required some specific tricks and sensibility to actually score, then there's really nothing unique about your use case to begin with, and maybe the product that you're building shouldn't exist. Maybe it should just be part of ChatGPT. So I think it's quite important to really engineer scoring functions. And if you sort of zoom out and think about it, just like the sort of end-to-end evals, I think scoring functions are actually one of the most durable things you can invest in engineering because they should survive as you change things. So if you change a model, you might rip apart a prompt, you might remove stuff, blah, blah, blah. But the way that you evaluate those changes actually shouldn't change that much. And so, you know, the depreciation on this engineering is actually a lot less than other kinds of AI engineering. In terms of like practically how to get started, I think it's quite simple. Unless there's some crazy stuff that you're doing and there's reasons for that, but also it's not super common. There's basically two kinds of scoring functions. One is a heuristic. You can write a piece of Python code or whatever you want, a TypeScript code that just, if this and that, blah, 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 return this minus that, heuristics. There's some pre-made heuristics. Braintrust, includes a bunch of them. You can also write your own or use whatever libraries you want. And then LLM as a judge. And LLM as a judge, I actually think of it a lot like you're a PM and you're writing out the PRD criteria for whatever the project is that you're working on. And you have a relatively dumb set of engineers who are working on the project. And so the more skilled you are as a PM and the more precise you are, the more successful your engineering team, i.e. the evaluators and the LLMs actually running the agentic task will be. And so if you put that PM hat on, then you can write some pretty good wording. And there's a bunch of pre-cooked LLM judges in Braintrust, but all of our customers, after a certain point, have customized all of these judges into essentially PRD wording that's specific to them. Maybe an analog would be like if your PM at Pylon were like, hey, please build this, like a copy paste of this feature from Zendesk, you'd probably be like, what? Whereas I think if a PM is like, hey, here's what Zendesk does, but we want to improve this thing, and we want to make this thing purple, and we want to have when you at someone, it pings them on Slack, or like whatever the details are. I think it's great to capture those in LLM scores.
And are there ever examples where LLM as a judge doesn't work, or you
All the
would
time.
say like you should never use it in these types of evals or use cases?
Well, I think there's a lot of cases where it doesn't work very well, but I think if you reframe the utility of an LLM as a judge from being a benchmark to being an anomaly detector, then I think it's actually okay. So I would always recommend having heuristic scores and LLM as a judge in a particular use case, and then run evals and build intuition as a team about what the differences between different metrics tell you about what might have broken or not broken. And so, yeah, I mean, I think there are definitely use cases where they're noisier than others. This has changed quite a bit, but I think visual taste is a good example. A bunch of our customers do, as I mentioned, like code gen type stuff. And one of the things that really used to not work very well, although it sounds quite appealing, is like render a screenshot of a generated UI and then analyze it and try to detect whether it's like a good UI or not. And for a long time, it was better to just look at the code and try to determine that. Things have changed a little bit, but that's an example where that signal was pretty noisy. But what's interesting is to actually make that signal work, you need to render the UI. And then if you're a human and you're debugging these anomalies and you have a rendered version of the UI right there, it's actually way faster for you to look at the difference and say like, oh yeah, this UI actually sucks. And so it still ends up actually being quite helpful.
Yeah, and actually this next question is, at what point do you decide whether a human should be in the loop of this evaluation cycle, and in what types of examples would you ask for just human manual evaluation to occur?
Yeah, I think the way that I think about it is very team oriented. So if you're at a company, like Stripe's one of our customers, for example, they have some pretty interesting requirements and sensitivities around different use cases and what they can ship in different use cases and whatnot. And I think as a team that's building an AI product, at least for the next 24 hours and maybe for the next few years, you are accountable for the quality of the product that you're producing. And what I mean by that is if you're in a regulated space, you're literally accountable to regulators, and if your company screws up, you are to some extent accountable for that. And so it's important for you to build systems that allow you to trust what an AI is producing and trust your ability to evaluate that. And on day zero, if you're in a regulated use case, it is highly unlikely that you're going to let GPT-4.1 run free and use a pre-made LLM as a judge and determine whether or not something is financial advice. Nor should you, right? However, what you should do is still run that LLM as a judge, still manually review the outputs and the scores, and start to understand what are the cases where this thing is doing well and it's not. And maybe out of that, one thing you could do is develop a heuristic. So you could, I'm just making this up, you could write a regular expression that looks for keywords that indicate that something is financial advice and make sure that none of those words exist. And if none of those words exist, then maybe you know that this thing isn't financial advice. Or conversely, if any of those words are there, you know that it is. And so you can use a heuristic signal that is something you can immediately trust as a way of eliminating a bunch of manual work. And then maybe the next time you're evaluating, you don't look at all the things that are filtered by this heuristic, but you look at the subset that remains. And I think you can iterate on this process. We had a really fun dinner a Greylock dinner a while ago in New York. And New York's interesting because there's a bunch of consumer companies and a bunch of banks. And so we had Connor, who's from Loom, and he runs a product for their AI stuff. And he was sitting next to someone, I forget which bank it was. I'm probably not even allowed to say, but some fancy bank person and Connor. And we kept asking these questions of the table like you do at a dinner, like, hey, are you worried about guardrails? Are you worried about what's the worst that can happen if an AI says something bad? And Connor's answers and the bank guy's answers were just totally different. And I think that sort of speaks to it. Like probably, well, I know for sure the amount of manual review Loom does is a lot less than some of the financial customers, for example, that we have.
Yeah, that makes sense. I have two last questions, and then we're going to open it up to the crowd. If there is any questions, Ankur is happy to answer them. So next question is, organizationally, how do you see the best-in-class teams manage evaluations? And what I mean by that is, who's responsible for them? How is this responsibility shared across engineers, but you also mentioned PMs and more?
Mm-hmm. Yeah, so I think evals should be owned by the product team that is shipping a feature. And often the product team includes different kinds of folks. So a product team might just be product engineers. That's fine. It might be product engineers and product managers. It might be product engineers, product managers, and one ML scientist or more data science-y type person. It varies per company. It's totally fine. But I think the team that actually owns a feature is the one that should own the evals for that feature. And the most successful companies that we've seen that actually do this well, recent example of a company that's implemented this, I think, exceptionally well in the organization is Ramp. They started with evals being part of their applied AI team, and that allowed the people that were actually building the AI features to shape how they do evals together with the more kind of platformy, systems-y people that get really excited about something like Braintrust. And so that team sat together, they figured out a bunch of stuff, they built a bunch of really good examples within the company of how to do evals, and then they actually moved evals into the dev platform team. And that allows them as a company to make evals part of what literally every engineer has in their toolbox as they're building features. And guess what? That means that every team there is able to build AI features. And so we've actually seen the very best-in-class teams kind of move towards this platform model where the team that owns organizational-wide things like observability and testing and source control actually owns evals as well. And there's a bunch of tricks you can do. I'll just call out one of them that I think is really effective. If you implement observability with something or specifically Braintrust, something like or specifically Braintrust inside of your internal AI gateway, it's really effective. Like almost every company has some kind of AI gateway, and if you don't, I would encourage you to invest in one. It's a nice way to it's a nice layer at which to implement a bunch of like policy logic and model routing and cost tracking, like whatever you need to do. But what a lot of great people do is they actually add logging into that as well. And so what that means is like if you're a new team and you don't know what evals are, you don't care, you just want to like use Claude 4, you can get access via this gateway and then start using the model, and everything actually gets logged for you. It's just the LLM calls, but they're still all logged. You can search for them. You can look at metrics over time. Maybe you're not even doing that though. What will eventually happen is if your product starts working, you'll be like, hey, maybe Corinne's running the team. Hey, Corinne, I'd like to start doing evals. And Corinne can say, great, here are all of the logs from people using your product over the past 3 months. Let's get started and actually start crafting this into something that you can use to make the product better. And there's a lot of tricks. Like you can use distributed tracing so that as we as a team want to add more context and structure, like maybe we're building an agent and we want all the LLM calls to be grouped together so that we can see the whole flow, you can kind of layer that onto the platform. So that's generally the architecture we recommend.
Awesome. And the last question is, obviously the ground is always shifting underneath us, both at the model layer and also at the framework layer. If we zoom 2 years into the future, how do you think evals are going to be different, particularly for agents? And what does that mean for Braintrust?
Yeah, I think that evals actually have not changed much over the past several years. Like I've been doing evals since 2016, and one of the reasons I actually was excited about starting Braintrust is from then all the way through when I was working at Figma, very little had changed about evals, even though the things we're evaluating and some of the metrics and blah, 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 all this stuff is changing, but the discipline itself hadn't changed. And that gives me a lot of internal conviction that 8 years from now, evals will still be very relevant, and they'll be kind of like the core driver for how people build great AI software. But I do think that the methodology, the implementation of actually running evals has changed quite a bit, and it's going to continue to change. So from back in 2016 to now, probably the biggest difference is when you run an eval, the amount of effort it takes to incorporate what you learn from the eval into the next iteration is very little. So back then, when you ran an eval, you might need to retrain a model before you run the next eval. That might actually take some time, and it's not something you can just do in an afternoon. Today, actually, what's kind of crazy, even across like the free users who sign up for Braintrust, the average org runs 10 evals a day. And obviously, the people that are running evals at scale, that's an average, right? The people that are running them at scale are running like many, many, many thousand per day. And the reason that's possible is because large language models let you prompt them. And so you can very dynamically change what you're testing. Now, what I think wasn't possible until very recently and is going to change evals in a very significant way again is that now the most recent vintage of models are actually able to look at eval results and automatically suggest and in many cases even implement those improvements. And so I think we went from extremely slow updates that were very manual to very fast updates that are very manual. And I think we're going to move towards even faster updates that are partially or even entirely automatic. And the way that we as humans are actually going to interact with evals is going to shift from looking at a dashboard, walking away with some inference, and then type, clack, 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 whatever, into the next version of something to test. I think it's going to be more like, hey, we look at something, and maybe an LLM system is suggesting or contextualizing what we should change and why, and maybe we consider 2 or 3 different options, or maybe we look at 3 or 4 different changes and what the eval results are, and actually think like, hey, which one do I feel like is better, and how do I encode that in the product? So I think there's going to be a really big shift, and we're very excited about that. Stay tuned. You will see some. It won't take us 2 years, but you're going to see some very exciting stuff from Braintrust on this front.
Awesome. Any questions from the audience?
Hi, I'm Pradeep. So my question is about essentially evaluating states of actions. Like you can today evaluate a final action, but don't you think that there should be a system to kind of evaluate a state of actions from start to finish, given that agentic behavior is becoming so common?
Yeah, I think first of all, you should experiment with evaluating different things, and I think the test of a good eval is twofold. One, when you run the eval, does it give you interesting insight? And 2, when you run another eval or you change something, is the eval still relevant? I think where I've seen what you're describing work well is when you capture individual steps along the way and you figure out how to evaluate them in sum. Where I've seen it go badly is kind of like if when you write a unit test and you let's say you're creating a front end app and you assert that every single div is in a particular place in the hierarchy, and then you change one thing about your product and then that test breaks. I think you don't want to create evals that are so glued to a specific pathway of doing something that they become brittle as you actually want to make changes. And there's a little bit of an art form to that. And honestly, I think that you should experiment with it, and you should try to figure out an engineering culture and a set of tools, whatever it is, that make it easy for you to try ideas out, and then just keep experimenting. And you'll sort of figure out after a few weeks what has become durable and what is just kind of slowing you down.
Hello.
Hello.
I have 2 questions for you. The first one was regarding Brain Store.
Yes.
So it's one of the first databases that I think is kind of reimagining what it means to store data in this new LLM world. So I wanted you to kind of walk through what your customers were asking and how that kind of translated to the design phase and how BrainStore differs to traditional databases. That's the first question. The second question is regarding LLM as a judge. I'm wondering if there's any customer demand for a more, for lack of a better word, invasive type of intervention once, you know, a customer's LLM or agents is not operating the way you would like to. So kind of Braintrust on behalf of the customer intervening or steering the LLM or the agentic workflow to kind of, I don't know, make sure that you're within the thresholds that the customer provides. So yeah, if you could give some insight on that too.
These are great questions. Okay, so let's talk about BrainStore. Before Impera, actually, I worked at a database company called MemSQL, now called SingleStore, and I love databases. We built a bunch of database tech at Impera as well. So, you know, definitely a topic that's near and dear to my heart. However, I also know how painful it is to build them. At MemSQL, I think we spent 2.5 years before we had anyone using our database product in some sort of repeatable way. Like, you know, the n plus first user could use the same thing as the nth user. So, you know, databases are really challenging. And when we started working on Braintrust, we tried using the sort of classic cocktail of available databases out there to build a product like ours, which is Postgres, ClickHouse. We dabbled a little bit with Redshift and Snowflake and stuff, and hey, maybe we can just sell to people who are running these things. And it turns out like everyone's running different stuff, even though all these products are great. What's interesting is we ended up just using Postgres, and then a little bit later we started using ClickHouse. And around, must have been a little under a year ago, so like last June or July, the Notion people, who I think are generally 6 months ahead of everyone else in terms of product, service area, actual adoption of their AI products, and so on, they were like, hey, Braintrust is really slow. And that, you know, I care about performance. That made me quite sad. As one does, you know, it's like, oh, what are you guys doing? Maybe, you know, blah, blah, blah. And then we dug into it, and their logging volume was going like this. And they also had more people working on AI than they did before and anyone else. And they were just typing stuff like, hey, how do I, or, you know, searching for stuff in prompts. Like maybe Corinne's using Notion AI, and she pinged someone like, hey, you know, I wasn't able to turn this thing into a table. Someone might literally search for something like Corinne and table and try to find the example so that they can debug what she's working on. And at the same time, models were also changing. So the context window has gotten a lot bigger. The average span that someone logs in Braintrust nowadays is like 50 kilobytes. In traditional observability, it's about 900 bytes. So the shape of data is, you know, changing at the same time. People are starting to work on agents and this for loop with tools thing. You know, sometimes you're trying to evaluate, you know, all the states or intermediate states of a system. So you start logging a bunch of states. So they were logging like, you know, state from the Notion documents, and so they were like really big rows. And the TLDR is that the stuff out there in SQL land, none of it was able to support this use case. And we looked at it and we're like, you know, none of this stuff can support what Notion is trying to do now, but this has to be like at most 1% of what people are going to be doing a year from now. And that's, I think, pretty much turned out to be true in terms of how everything has grown. And so we, at this point, we had a bunch of benefits. One, we had a bunch of customers. You know, then soon other people started complaining. They were all complaining about the same thing. We knew exactly what the workload was. We knew exactly what the data shape was. We knew how to build this kind of software. The 3 people that worked on Brainstore were me, Manu, who's my brother, and he interned at MemSQL when he was in high school, and so he knows this stuff pretty well too. And then this guy Austin, who was one of the first engineers at Impera and did a physics PhD before that. Super sharp guy, also really into this kind of technology. And so we were like, we kept trying to use stuff. We ran a bunch of benchmarks, and then eventually we made a benchmark that was like 100 times what Notion was trying to do. And we benchmarked everything, and literally nothing worked. And we dug in. I read like, an embarrassing amount of ClickHouse's source code, and we just tried to figure out how we're going to do this. We realized we can't. And so that's when we realized we need to build Brainstore. And there's this really cool library called Tantivy, which is a Rust port of Lucene, which as a project has been very impactful. It's the basis of Elasticsearch and other stuff. And Tantivy, just raw string crunching performance, was the only thing that we tested that was actually able to process this much data and index it effectively, other than just stuff that we hand wrote, which we didn't want to write everything from scratch. So we're like, okay, this thing is a kernel of something that we can probably use. And so we broke ground in October of last year. We actually had a document that was like, this is everything we need to do to turn Brainstore on, and this is all the shit that we don't need to care about. This is like probably the 4th database system I've built, and I've never had anything like that. Like, this is the only time we just really knew exactly every in and out of the workload and what mattered. And so we broke ground in October, and we shipped it to Notion in January and everyone else in February. And I remember the day that we turned Brainstore on for everyone, our infra was melting, and Brainstore, we were like, okay, the only way we're going to get out of this is by turning Brainstore on for everyone. And rest in peace. That's also the night that ClickHouse died, and it's never recovered. So it was like, it was a really interesting process there. But that's the story behind Brainstore. And I think what's really great is that it's enabled us to really control our destiny. So now people ask us about use cases that they are way outside of what traditional relational databases can do, and we're not encumbered by the technical debt that comes with actually building on top of a relational database that you can only really mess with through this interface called SQL. So that's been really great. Like, I think we can be much more aggressive and offensive about use cases that we want to tackle that are a little bit more interesting. Your second question about being more invasive, I think this is a great question. And actually, I would say that there's a gradient from guardrails to evaluation. And it's, in traditional engineering terms, it's like doing something synchronously versus doing something asynchronously, and all the trade-offs that come with it. So an eval is like a very asynchronous way of assessing and intervening with an AI system. It doesn't block anything. It runs behind the scenes. You can react to it as quickly as the eval completes, and then do whatever you want with it. And a guardrail is very synchronous. So it runs on the critical path of whatever your AI system is, and it will likely slow it down, but it will prevent, it from producing bad results. And the reality is, at least the world that we live in, almost no one runs guardrails, and almost everyone runs evals. And I think that is primarily because, one, there's no good practices around guardrails, but two, the performance implications of using guardrails and the additional uncertainty is actually quite high. So I think as we, as an industry, come up with ways of solving that problem, and that could be, so I was talking to someone earlier about GPT 4.0 Mini, and I think I haven't really evaled 4.1 Mini so much myself, but one of the interesting things about it is, despite how cheap it is, it's actually quite slow. Like, it's only as fast as GPT 4.0. Probably not a great candidate to be a guardrail. But if let's just say that GPT 4.2 Mini is like absurdly fast, like you can process 10,000 tokens a second or something, maybe suddenly that changes the dynamic, and it makes sense to actually shift the gradient more towards guardrails and maybe take evals that you're doing offline and actually turn them into guardrails. From a product and tech standpoint, we're very prepared to do that at Braintrust. I have a branch on my laptop, actually, that that lets you do this. But from a product standpoint, it just hasn't been something that people seem ready to really do. If anyone here is trying to do that and they want to chat about it, I'd love to learn more.
Hi, thank you for a very inspiring talk. I'm Kui from Sumo I have 3 questions for you. The first one, as I'm listening to what you talk about, I see 3 levels of evals. One is at a single prompt level. Second is at a single agent level. The third perhaps is a multi-agent, building a full AI system with multiple agents collaborating together. So my question to you for the first question is where you see, as I jumping from one level, AI from single prompt to single agent to multi-agent, what's from the eval standpoint, what's the remain as consistent? What's are the net new challenge we have to deal with? The second question, as I thinking through your vision for the near future was coming, do you predict this eval things itself becoming an agent, a dedicated eval agent? So, and a related question, the second part is, what as eval becomes still in the very early phase for many other companies, where you see this interoperability or standard-based evals, because everyone has its own eval scores, where you see there is any potential that the eval result can be interoperable from vendor to vendor? So sorry for too many questions, but your talk is really inspiring.
They're great questions. The first question, I think, as you go from single prompt to all the way through multi-agent, you are inherently building an increasingly complex system. And I think in traditional software, there's this concept of modularity, and you can test something, and then if something is well tested and you build on top of it, then that is also equally well tested, right? Because you're building on top of something. In AI, one of the things that just turns out to be true is that modularity doesn't really work that well. So if you have a single agent system and you test it, you get very excited, and then you have a multi-agent system, the single agent of that multi-agent system might just behave very differently in the context of the multi-agent system than it did as a single agent. And so I think it is almost always a bad idea to start with a modularity assumption when you're trying to evaluate increasingly complex systems. And I think the best teams that I've seen are actually set up so that when they want to try a new architecture, or they want to try building a new kind of system, the agility with which they can go from 0 to 1 is very high. And so I think there's actually limited value in designing components that you can add up together and expect something to work very well. On the other hand, if you build, for example, we'll get to this with question 3, but if you build really good scoring functions that represent the truth that you're trying to assess in the context of your use case, then who cares whether it's a multi-agent system or a single agent system, whatever. It's quite easy to reuse those actually for new systems. That said, I think once you have something that works end to end on a complex system, picking apart into pieces that are frequently broken and evaluating them can be quite useful. And if you're lucky, when you iterate onto the next system, you'll be able to reuse some of that incremental work. But I've seen teams struggle when they hang on to prior work or work on simpler architectures as they approach new problems. And I've seen teams succeed when they're very good at just throwing everything away and starting over, and often ending up with something simpler. Remind me your second question.
Agentic evals.
Yeah, the answer is yes. That one's very simple. I think, the answer is yes. And we have we'll share some cool stuff about how we think about it. I'm sure that there's a bunch of people thinking about it. But the key thing that's changed is that I think the most recent vintage of models are actually meaningfully capable at reasoning about prompts and model tasks themselves. To put this in numbers, the best performing model that we see is 24 times better than the leading model from a very popular vendor of the previous generation, and about 6 times better than the next leading model from another vendor. So this particular type of problem is getting like radically better. And a year ago, the results were just terrible. Like we rerun tests on this often. So I think it's going to be quite exciting. The third question was around vendor neutrality and sharing stuff. So I think the interesting thing is that anything that's pretty common across customers gets rolled into an LLM pretty well. And I'd say like both customers who are trying to solve relatively unique problems and LLM vendors who feel very saturated on generic evals are quite frustrated with generic evals. And that applies, I think, both to scoring functions and especially to data. Like MMLU, for example, is just a completely meaningless thing at this point. And I think the art of releasing an AI model or a really LLM-heavy product and showing a bunch of bar charts about performance, that is like it's all marketing, and it's like writing a white paper or something. There's very little science that goes behind it. There's some companies that claim that they create evaluation models and they post benchmarks about them, and you literally can't run any of their evaluation models. So it's like, what is this benchmark? So I think that we have to be careful about that, and I think that likely means that there will not be really useful reusable things across customers. However, I do think that something that's quite broken today is information exchange across companies in the same space and information exchange from companies to LLM providers. There's kind of this, in some ways, adversarial relationship. Like maybe in your space, you'd be not super excited about like Datadog seeing some of your evals or something, but you might, there might be opportunities for like 1 + 1 = 3. And I think that these sort of market dynamics haven't really formed yet. It'll be interesting to see how they do. I'm relatively optimistic that there can be a good exchange between companies and LLM providers, but most of our customers, when we talk to them, are quite afraid about this because they don't want to surrender their data and lose the thing that sort of makes them, I think, quite unique compared to other people who have access to the same models.
Well, everyone, the Braintrust team is going to be here for at least the rest of the night. And actually, they're going to be in the corner showing a demo if you're interested in seeing more of the product. And actually, if you're a Braintrust team member, can you raise your hand really quickly? We have a bunch of people in the back. So lots of opportunities to ask more questions. Please stay, mingle, meet the rest of the crowd, have some food. And Ankur, thanks for joining us.
Thanks for having me. Thanks for all the great questions.